Hey guys, welcome to the channel. I brought you a question, or should I say two questions. One of them asks, which one is bigger, 2 to the power 300 or 3 to the power 200? This version is significantly easier to solve, should take 30 seconds to solve, than the next one, which asks 2 to the power 49 compared to 5 to the power 22. So let's get to it. As I said, the first one is fairly easy. In this kind of question, either you should make the base the same or the power the same. And from looking at it, it's obvious that we can make the power the same. So if I rewrite 2 and I take the 3 out, 2 to the 3 to the 100, and then I compare it to 3 to the power 2 to the 100, since this is 8 and this is 9, we know that this is bigger. And not that this is bigger, this is significantly bigger than this, because 9 to the power of 100 is order of magnitude bigger than 8 to the power of 100. Now let's shift our attention to more challenging one, which is ask us to compare 2 to the power 49 and 5 to the power 22. Okay, so here base are not the same, powers are not the same. Also, we cannot find any relationship between power, so we can bring it to the same power. One way to solve this is to bring 5 to the base of 2. So we know that 2 to the power 2 is 4, 2 to the power 3 is 8. So the question is 2 to the power of what is 5? Basically, we need logarithm of 5 in base of 2. Of course, I don't have a calculator, so I can estimate this number. If you remember how the log curve looks, so at 1, it is 0. We know at 2, it is, at 4, it is 2. And at 8, it is 3. Now the question is, what is the amount at 5? So if I do a linear approximation, and the curve already curves down, so let's say this is the linear approximation, I need basically this value, right? So if I do linear approximation, from 4 to 8, we had 1 degree increase. From 2, we went to 3. So each unit increase in x-axis will give us 1/4 increase in y-axis, right? So from 4 to 5, we should go from 2 to 2.25, which is only 1/4. So we can approximate this as almost 2.25. Of course, the actual value will be slightly higher, right? Because we approximated this value, but the actual value is here. But we keep that in mind, that the actual value could be slightly higher. So let's write that down, 2 to the power 49, and then now I can write it 2 to the power 2, 25 to the power 22. And if we multiply that, 2 times 2.25, it becomes 4.5 times 11, it becomes 49.5. And 5 to the power 22 is bigger than this. So let me write this down. Actually, I can remove this. And say 5 to the 22, we know that the actual log is bigger than 2 to the 25, so it's bigger than this. Now let's compare these two values. 2 to the power 49.5 is bigger than 2 to the power 49. And since this one is bigger than this, we can safely say 5 to the power 22 is bigger than 2 to the power 49. So this is one solution to use logarithm, but there is another solution. As I told you before, when you see a problem, usually there is some pattern in designer head that you have to figure out. So let's do that. Again, we have 2 to the power 49 and 5 to the power 22. Let's write down some of these powers and the values. So here is power, here is base, we have 2, we have 5, we have 1, 2, 3, 4, 5, 6, and 7. 2, 4, 8, 16, 32, 64, 128. Here we have 5, 25, 125, 625. Actually, it's already bigger than what we have here. So either we can compare 2 to the power 5 to 5 to the power 2, but these are not very close. The better option is to take 5 to the power 3 to the 2 to the power 7. Also, we see this pattern. This is a multiplier of 7, although this one is not multiplier of 3. So let's rewrite that. So 2 to the power 49 is 2 to the 7 to the 7, right? Which equals to 128 to the 7. This one is bigger than 125 to the 7. And you can write 125 as 5 to the 3 to the 7, which is 5 to the power 21. So if this was 5 to the 21, we could say 2 to the 49 is bigger. But seems that the designer is playing a game with us. So he didn't want us to give us that easy. So we have to figure out if this side, which is 5 to the power 21 times 5, if this 5 makes this side bigger than this. How we can do that? If we ratio between 128 and 125. So let me write down what we need to. So we have on one side 128 to the 7, and the other side we have 125 to the 7 times 5, right? There is one extra 5 that we cannot judge. And we don't know the relationship between these two. I can bring 125 to other side. So I will have 128 to 125 to the power of 7, and I need to compare it to 5. So if this side is bigger, then 2 to the power 49 will be bigger. If 5 is bigger, which means that 5 to the 22 will be bigger. So if we see there is a 3 unit difference over around 100, so this will be around 2%, 3%. It will be, let's be conservative and say it is 3%. Let me erase that for you. There is one limit formulation that we need to know. So for 1 plus x to the n, when when x goes to close to 0, x goes close to 0, this could be approximated with 1 plus nx. And you do it daily basis also. For example, if in market you make 3% yearly, after 7 years, you roughly expect 21%. Although your actual return will be more than 21% because this is exponential growth. But let's use that estimation. So this to the power 7 will be 1.21. We want to compare it to 5. It will be bigger than 121, but it will not be twice of this value. It could be 30, 35%. Still, this is less than 5. So from this, we can say that 2 to the 7 is less than 5 to the 3 to 7 times 5. Or in other words, 2 to the 49 is less than 5 to the power 22. If you remember, 2 to the 49 was bigger than 5 to the 21, which means that these numbers are not orders of magnitude different. Even multiplying one side by 5 will change the direction of relationship. So, hope you enjoyed this beautiful question. Please like, subscribe, and I'll see you in the next video. Have a good one.